Today's lesson is on naming organic compounds when we add functional groups to our hydrocarbon chains. So a hydrocarbon is a carbon chain with hydrogens on it. And then if we add something different, something other than carbon and hydrogen, we're adding what's called a functional group. And then you'll notice on your periodic table, we have what are called R groups, which signify the rest of the chain as we go along. So functional groups it is today. You're going to want to have out your reference table to table R. So that table R is on page 9 of your reference table. It's a new table for us, and it explains the different class of compounds. Those are the functional group names, and what actually the functional group is, what we're adding. So table R for today. How exciting. The first functional group to go over today are what are called halocarbons. Halocarbons are also called halides. So a halide is anything from group 17 of the periodic table. Group 17, do you remember what that group is called? Yep, you got it right, the halogens. So a halogen is also known as a halide. So halocarbons are also called halides because they're halogens. So this is when we have a hydrocarbon chain and we add fluorine to it. That would be called a fluorocarbon. We add chlorine to it. That'd be called a chlorocarbon. Bromine to it, bromocarbon, or iodine to it, called an iodo-carbon. And you'll notice on table R, it has these 4 listed with these names. None of this you have to memorize. So you just have to look, hunt and search, find it, identify, and it'll tell you how to name them. So you may have heard of chlorofluorocarbons before, CFCs, the things that destroy the ozone layer that are found in aerosol cans. Well, chlorofluorocarbons are hydrocarbons made with chloro and fluoro groups attached to them. So you're going to have chlorine and fluorine attached to an organic chain. And those would be our CFCs, or chlorofluorocarbon. So you learn something new every day. So in this molecule here, and this is something you'd want to write in your notes, so you'll be pausing this video as we go along, we have a 3-carbon chain. They have single bonds. So a 3-carbon chain with single bonds, we name that first. That's called propane. Remember, we name from the right and we go to the left. Now on this propane, there is a chlorine. So a chlorine is a chloro group. So that's the halide, chloro. So this is now a chloropropane. And we have to name which carbon is the chlorine on, because it could be on the first carbon, the second carbon, or the third, which the third would become the first again, because it could go first, second, third. So you can have chlorine on the first carbon, or it could be here on the second carbon. So this is 1 chloropropane because it's on the first carbon. If we move it to the second carbon, you now have an isomer of chloropropane, and you would have 2 chloropropane. So for each of these, please pause the video and write down each of the compounds with their names. And what I'll be doing is explaining each one. So this hydrocarbon, we've got a 1, 2, 3 carbon chain with a double bond. So this is meth-eth-prop. So this is a prop with a double bond, so it's called propene because it's an alkene. Now, we normally would have to number where this double bond is, but this one's on the first carbon, second, third. Or if we turn the molecule around the other way, it moved here, it'd still be on the first carbon. So we don't need to say it's 1 propene. It's just understood it is. Then we'll notice here we have our halide group, or our halocarbon, bromine. So this is a bromopropene. And the bromine exists on the second carbon. So it's 2 bromopropene. In our bottom molecule, we have a 1, 2, 3 carbon chain with single bonds. So that's called a propane. Prop for 3 carbons, ane for alkane single bonds. Now there are 2 halides on this one. They are the same each time, but we have a chlorine and a chlorine. So this is a dichloropropane, di signifying 2 chlorine groups. So dichloro And where do those chlorine groups live? They live on the first carbon, the second carbon of that chain. Now, we wouldn't say this is the first carbon because we got a number from where there's something special. We start off first with is a double bond or triple bond. We'd start there. And then if there's none of those, all single bonds, you start, where's the first special group? So the first chlorine is on the first carbon, second chlorine on the second carbon. So this is 1,2 dichloropropane. So it's very specific. It's a propane, 3 carbons, dichloro, 2 chlorines. Where do the chlorines live? First carbon and second carbon. A very specific address of how we write it and how we name it. So things will get a little more difficult for you is that you do need to memorize that whenever we name these kind of organic compounds, we have to alphabetize the halogens if they're in there or the special groups. So we're going to put them in alphabetical order. So in this molecule here, we have a bromine, a bromo, a fluorine, a fluoro, a chlorine, a chloro on a 1, 2, 3, 4 carbon chain. So a 4 carbon chain is methylpropute. So bute is the prefix, ane is the suffix because it's an alkane, single bonds. Now, where do we put? Is it a bromobutane, fluorobutane, chlorobutane? What could attach? Well, if we're going in alphabetical order, the bromo comes before the chloro, which comes before the fluoro. So B before C before F. And we number them accordingly. Here's our, we wouldn't start here because that has nothing on that carbon. So we start where's the first special thing. Then there's our second carbon and our third carbon. So this is 1 bromo, 3 chloro, 2 fluorobutane. So 1 bromo, 3 chloro, 2 fluorobutane. On this bottom one, because it's both fluoros, we don't need to alphabetize them because it's just fluoro, but there are 2 fluoros, so it's difluoro. So to name this, we look at the carbon chain. 3 carbon chain, 3 is prop on table P, alkane on table Q, ends in ane, single bonds. On table R, F and F, those are fluoros. And because there's 2 fluoros, it's difluoro. And where do those fluoros live? Each fluorine, there's one at the, has to be signified. Where is it? There's one on the first carbon, one on the second carbon. So this is 1, 2 difluoropropane. Once you learn how to name these, you feel so much smarter. And if you name a few of these things, your friends just think you're brilliant. If your parents are listening to this and helping you with this work, they may need a drink for this one. This group, when we're adding it from table R, is the OH group, which you learned in acids and bases signifies a base. But when there's carbons and hydrogens, instead an OH signifies that it is an alcohol. So OHs are alcohol groups. They have the general formula ROH, R meaning rest of the carbon chain, so the carbon chain, and then there's an OH on there. An OH with a carbon chain signifies we have alcohols. So if we had to draw 2 isomers of propanol, we need to first think about what does this compound have in it. Prop stands for, when we look at table P, 3 carbons, and we've dropped the E off the end of it, so it would have been propane, stands for it has just a single bond, so sharing of 2 electrons. And then on the end, when you look at table R, the ending of these words is OL, so it's all for alcohol, just like in the name, they're going to end with an OL. So 3-propanol is a 3-carbon chain for prop, single bonds for the and, because it used to be propane. Now, where one of the hydrogens used to be right here, that hydrogen has been replaced by an OH group, a hydroxyl group. That OH now makes this propanol. Because the alcohol group is on the first carbon, first, second, third, it's on the first carbon, we call this 1-propanol. In the isomer of 1-propanol, we have what is called 2-propanol. 2-propanol, we have the prop, 3 carbons, and meaning propane, single bonds. And since it's 2-propanol, that signifies that our alcohol group or hydroxyl group is on the second carbon. And you can see no matter how we number it, first carbon, second carbon, third carbon, or first, second, third, it's on the second carbon. So this is 2, that's the carbon it's on, prop, and all. And the alcohol, just like the word alcohol, that's the sound at the end of this word. So 2-propanol. And we need to know that sound very well because we also have what's called anal. And anal is different from an anol. Alcohols are anols. The more carbons you have in a chain, the more isomers you possibly could have. So lots of isomer questions when you have the same molecular structure but different, same molecular formula but different structural formula. The more carbons you have, the more of those isomers you can have. So if we were to look at butanol, right away just looking at this word, but means how many carbons? 4 carbons. An would be ANE, that means it's a single bond, so a sharing of 2 electrons. And OL at the end means that's an alcohol or an OH at the end. So using table P, table Q, and table R, we can detective out all those different things right from this word butanol. So what are the 4 isomers of butanol? Well, you can have one butanol in which you have your alcohol group, this OH, on your first carbon. We don't call it 4-butanol because 4-butanol would be 1-butanol. We always go with the lowest number. In this example, 2-butanol, we still have our butane, but now the alcohol group, the all group, the OH, is on the second carbon, so 2-butanol. Now, if we move the carbon to here, will that be 3-butanol? Nope. That would be 2-butanol as well because we'd start now with our first carbon, second carbon, third carbon, fourth carbon. So we don't have a 3-butanol in this situation. So what will our other isomers look like? To make the other isomers, we take our 4-carbon chain and we make it a 3-carbon chain and put the 4th carbon off of that. So this is an isomer of butanol, even though it's not a bute anymore. Now the longest chain is 1, 2, 3 carbons long with a methyl group on it. So an isomer of butanol is 2-methyl-1-propanol. So 1-propanol, meaning on the first carbon, there's an alcohol. There it is. The 2-methyl means on the second carbon of this 3-carbon chain, there is this methyl group. Remember, methyl is CH3. So we have a methyl group on the propane group with the alcohol group on the first carbon. So it's 2-methyl-1-propanol. Now, if we take, for the 4th isomer, take the alcohol off what was the side and put it in the middle, now we have another isomer, same molecular formula, different structural formula. So we're moving things in how it looks. Now we have the alcohol group on the second carbon, and we have the methyl group on the second carbon. So this is 2-propanol. That signifies it's an alcohol with the OH group on the second carbon. And is also 2-methyl because the methyl group, this extra CH3, is attached to the second carbon. So the whole organic compound would be called 2-methyl-2-propanol. You are writing all these in your notes, right? Of course you are. Go back and do it if you forgot. The next functional group to discuss are called the aldehydes. The aldehydes, when we name them, we drop the E at the end and we add an AL. So like propane, you drop the E, so it's propan, and then you put al at the end, so propanal. The functional group is what's called a CHO, which is a general formula. You have the rest of the carbon chain, and on the end of the carbon chain, you have a hydrogen on the last carbon, and you have the carbon also double bonded to an oxygen. So this right here is the aldehyde group, and then the R stands for the rest of the carbon chain that will go out from there. So you may have heard of our first aldehyde here. The first aldehyde I have is got a common name, formaldehyde. It's got the word aldehyde right in it. The IUPAC name is methanal. Please don't pronounce it the way it's spelled. This is methanal. And what we have is a carbon chain. So it's not much of a change. It's just one carbon double bonded to an oxygen to an H. So here's our aldehyde group. Here's the meth group. So it's methanal. Remember, we say anal, not how it's spelled out here. Common name acetaldehyde. If you've ever used torches, you may have used this. This is ethanal. Ethanal has a carbon chain attached to our aldehyde group. So here's our aldehyde group on our end carbon, and then we have the carbon chain coming off it. So we have a 2-carbon chain. That's the prefix eth from table P. And then a double bonded O to an H on the end carbon is an aldehyde group. So this is single bond, ethane, drop the E, add the al on it, it's ethanal. As you're putting all these in your notes, you're thinking, oh gosh, look at all these different groups. Well, you'll see table R, it's a full page of these groups. But luckily, because you have table R in the reference table, you really don't have to memorize these. You just have to know how to use them, identify them, and the biggie is naming them. And on table R, where it says example, it shows you how to name them. So the next group is a ketone. The ketone looks a lot like an aldehyde, which we have a double bonded oxygen to a carbon. But in this case of a ketone, the ketone has the double bonded oxygen on a carbon that's in the middle of a carbon chain. So it's like a pendant hanging off of your necklace. It's in the middle of your necklace. We have R1, which is the rest of the carbon chain coming out on this side. There's a whole bunch of carbons. And then we have R2, that's the rest of the carbon chain coming out on this side. That's a whole bunch of carbons. So you can also think of, to get this oxygen, we need a key to get to it. And it almost looks like the keyhole, old salting key on an old lock. To name ketones, we drop the E at the end of like propane or propene, whatever it is, and we add "one" at the end of it. Even though it looks like it's spelled one, we're going to pronounce it as "one." So we're going to have a ketone, and it has right in the word the "one" on the end of it that we're adding in. So with our ketones, one of our common ones, you'll have the common name acetone. Ladies, you'll know that as your nail polish remover, or guys. Propanone is the IUPAC name for the common name acetone. Propanone is a prop, that's from table P, a 3-carbon chain. An looks like a single bond for ane from table Q, alkane. And then one, this O-N-E at the end, that signifies we have a ketone. So a 3-carbon chain. If we had the double bonded O at the end to be an aldehyde, this double bonded O is in the middle. We don't have to say this is 2-propanone because the only place we can have a double bonded oxygen is in the middle. So this is just regular old propanone. You don't need the number 2 there for to signify that carbon. So we see prop, 3-carbon chain, propan, it has single bonds like propane, and we add the "one" at the end of it. So propanone, because we have the double bonded O for the ketone group. In butanone, we also don't have to signify it's 2-butanone because whether the double bonded O is in the middle on the 2nd carbon or here on the 3rd carbon, the 3rd carbon, you would actually start numbering 1, 2, 3, 4. So it would become the 2nd carbon anyway. So this is butanone. Butan stands for butane. 1, 2, 3, 4-carbon chain with single bonds, butane. Then double bonded O on one of the middle carbons. So we have a double bonded O that signifies our ketone. So we call it butane, drop the E, so it's butan. And then the "one" for the ketone, this is butanone. So this is pretty tough stuff. We'll practice this some more. We're going to add more into it on tomorrow's lesson for Friday. That sounds exciting. So as Sheldon Cooper would say on the bottom, live long and prosper.